Hi guys, welcome back. So what we're looking at today is lesson 18, comparing populations using samples. So here are 10 random samples of 7th grade students' backpack weights. So we've got all these different samples. There's definitely some variability here. Some of them go all the way up to 18, whereas others never get higher than 9. So we've got a lot of variability here within our set. So what we're looking at is we want to take and decide which sample has the highest mean weight. Well, if we look at all of these, which ones have the highest overall values? Well, that's going to be sample 2. So sample 2. Which sample has the lowest mean weight? So we want to look for that lowest values. That's going to be here. We've got a lot of low values. So sample 8. So without even calculating the mean, we can take and look at these. So what's the difference between these two sample means? Well, if we calculated these, so adding up all of our points in here, dividing by how many there are, the 10, we'd get 9.2, whereas this one is 5.2. So 9.2 minus 5.2 is going to give us a 4-pound difference. So pretty significant difference. All of the samples have a mean absolute deviation of about 2.8. Express the difference between these two samples as a multiple of the mean absolute deviation. So if we take 4 and divide it by 2.8, we get 1.43. So taking the mean absolute deviation times 1.43 gives us what the difference is between our means. So are these samples very different? No, they're all fairly close. They're all within, 2 of each other. So no, they're not very different. Same population. All within 2 mean absolute deviations of each other. All right, remember our sample of the 10th grade student backpacks had a mean weight of 14.8 pounds. The MAD for this sample was 2.7 pounds. So what we're looking at here, and I'm going to write this out so you guys can see it. What is the difference between the sample means for the 10th grade students' backpacks and the 7th grade students' backpacks? So I'm going to write these out. I'll have the difference in the means as well as the multiplier. Here's the different samples. I couldn't fit 10 in there. I ran out of space, but it's 8.4 for the difference in means and 3.0 for the multiplier. So we could see these. Notice the multipliers all right in around 3. We're kind of averaging around 3. But I mean, there's some discrepancies. We go all the way down to 2 and all the way up to 3.4. So do you think there's a meaningful difference between the weights of all 7th grade and 10th grade student backpacks? Explain. So yes, mean is more than 2 mean absolute deviations, so meaningful difference. So typically if we have a mean absolute deviation more than 2, we're looking at a pretty significant difference, so there is a big difference there. All right, so a lot of comparing. So compare is your key word for this lesson. All right, steel from different regions. When anthropologists find steel artifacts, they can test the amount of carbon in the steel to learn about the people that made the artifacts. Here are some box plots showing the percentage of carbon in samples of steel that were found in 2 different regions. Was there any steel found in region 1 that had more carbon than some of the steel found in region 2? So if we look, region 2 only went up to about 5.63 or something like that, whereas region 1 went almost all the way up to 0.72. So yes, most had more than region 2. B, was there any steel found in region 1 that had less steel or that had less carbon than some of the steel found in region 2? So there was at least 1 piece of steel. So this is kind of the majority of our data is here in this right here. But we did have this low point way down here. So there's at least one piece had less. 2. Do you think there's a meaningful difference between all the steel artifacts found in regions 1 and 2? There is some overlap, but the boxes are so far apart that there'd be a pretty meaningful distance. So some overlap, but boxes significantly far apart. So yes. And for 3, which sample has a distribution that's not approximately symmetric? So symmetric meaning that these whiskers here would be about the same length, so that's definitely region 1. Oops, region 1. All right, for number 4, what is the difference between the sample medians for these two regions? So we're looking at 0.64 minus 0.47, which will give us a 0.17, so 0.17%. Express the difference between these two sample medians as a multiplier of the larger interquartile range. So 0.05 times 3.4 is going to give us 1.7. So if we took the 1.7 and divided by the 0.05, we would get that. For number 6, the anthropologist who conducted the study concluded that there was a meaningful difference between the steel from these regions. Do you agree? Yes. Sample medians greater than 2 interquartile ranges. So there is a significant difference in these. So a lot of comparing, both looking at medians, interquartile ranges, and means for these. All right, if you guys have any questions, feel free to ask. Have a wonderful day.